Your FastMCP server just got smarter. Now it can automatically notify clients when resources change, eliminating manual refreshes and keeping everything in sync. You'll see how 3 simple operations, adding a resource, enabling it, and disabling it, trigger real-time notifications that keep connected clients updated without polling. This pattern makes your server more responsive while reducing unnecessary network traffic.
At MCP resource, data / example. Def example resource, SDR. Return hello. Hash these operations trigger notifications. MCP, add resource, example resource. Hash sends resources list changed notification. Example resource, disable. Hash sends resources list changed notification. Example resource enable. Hash sends resources list changed notification.
This demonstrates the observer pattern combined with declarative resource management. Resources act as observable entities that notify clients about state changes, while the decorator syntax provides a clean way to define and register these resources without explicit event handling code. The pattern works by decoupling resource definition from notification logic. When you add, enable, or disable a resource, the framework automatically broadcasts state changes to all connected clients through a pub/sub mechanism. This keeps your resource implementations focused on data provision while the framework handles the reactive updates. This approach solves the problem of stale client-side resource lists in distributed systems. Instead of polling for changes, clients receive immediate notifications when resources become available or unavailable. It's particularly valuable in dynamic environments where resources may be added or modified at runtime, such as plugin architectures or microservice ecosystems. Let's break it down line by line.
At MCP resource, data / example. Def example resource, SDR.
The @MCP resource decorator registers this function as a managed data resource at the URI data / example. It transforms a simple Python function into a monitored resource that can trigger notifications when its state changes, enabling reactive systems to respond to resource modifications.
Return hello.
This defines the resource's return value, a simple string payload. In FastMCP, resource functions must return serializable data that the system can distribute to subscribers or cache for later retrieval.
Hash these operations trigger notifications. MCP, add resource, example resource. Hash sends resources list changed notification.
This registers the decorated resource with FastMCP's resource manager, making it discoverable and usable by other components. The operation emits a resources list changed notification to alert subscribers about the new resource, enabling dynamic system updates without restarts.
Example resource, disable. Hash sends resources list changed notification.
This temporarily deactivates the resource in FastMCP's registry, making it unavailable for AI calls. The notification system broadcasts this state change to all connected clients, ensuring they maintain consistent resource listings. This follows the standard enable-disable pattern for dynamic resource management.
Example resource enable. Hash sends resources list changed notification.
This re-enables a previously disabled resource, restoring its availability to the MCP system. Like add and disable operations, it triggers a resources list changed notification to ensure all clients maintain synchronized state. This follows the event-driven pattern where resource lifecycle changes propagate immediately to connected systems. Resource state management. The enable-disable pattern in FastMCP resources creates dynamic availability without modifying the underlying implementation, with notifications automatically propagating state changes to connected clients. Notifications only fire during active request contexts, not during server initialization, which can lead to silent state changes if you're not careful. This declarative approach lets you control resource visibility at runtime while maintaining clean separation between configuration and logic.
The resource that disappears from the list remains fully present in the code.